7 on your homework is a great question because it has you apply multiple concepts into one problem. And the math of it is really not that hard. So looking at number 7, what triangle do you have the most information about so far? Name the triangle with 3 letters. So we are focusing on the triangle for which we know all of the side lengths, well, the only triangle in the picture, right? We're focusing on BDC. We can determine if triangle BDC is acute, obtuse, or right. It's asking about angle 1, but we're not there yet. So we can determine if this one is acute, obtuse, or right. So we're going to do what we know how to do. We're going to write Pythagorean theorem backwards because it's a converse. And then we're going to give it a greater than or a less than symbol. So we've got 625 and 612. The inequality is hungry, and it eats the bigger number, so it's eating 625. And now we read what symbol that is. That is a greater than symbol. Greater than. Meaning that that is an obtuse triangle. Now, if that's an obtuse triangle, which angle is obtuse? Is it B? Is it D? Is it C? Yes, of course. It's the largest angle is going to be across from the longest side. So we now know that this angle is obtuse. Now, from last semester, we have in our pocket all these words. Alternate interior, same side exterior, corresponding, linear pair. And that's what we're going to use to finish this problem out. You can use same side exterior, but I'm going to go ahead and go with corresponding, okay? So if this angle is obtuse, then it's corresponding with this angle. That means they're congruent. They're the same measure. So if angle D is obtuse, then angle BFG is obtuse. Now, angle 1 and that angle, those are a linear pair. In a linear pair, the two angles have to add up to 180. So if this angle is obtuse, the other angle has no choice but to be acute. 180 minus an obtuse angle has to be an acute angle. So this one has no choice. The linear pair of an obtuse angle is an acute angle. So we use converse, then we use corresponding angles, then we use linear pair. The answer is acute. Number 9. In number 9, I see 4 triangles. I see 4 of them. 3 of them are what kind of triangles? 3 of them are right triangles. So on 3 of those triangles, we're allowed to use our theorem. We're allowed to use Pythagorean theorem. Now, we don't need to know this value right here. I could find it, but I don't need it. What I do need is to know all the sides of triangle ABC. When I know all the sides, I can classify it. So what we're really looking for is this side right here. In order to find that side, we're going to use our knowledge of right triangles. And we know that in a right triangle, a squared plus b squared has no choice but to equal c squared. 261 equals c squared. C equals the square root of 261. Now I'm actually not going to simplify that. I am not going to factor tree that because this problem is not asking me for AC. It's asking me acute, obtuse, or right. So I'm not going to waste time simplifying that number. What I am going to do is Pythagorean theorem converse. And I'm going to do converse with the sides of A, B, C. Now which one of those is my C? Good. You need to find out what square root of 261 is as a decimal, but you'll realize it's 16 point something, so 17 is our longest side. B squared, A squared plus B squared. Okay, we're not going to touch our calculator. You memorize the ones from 1 to 20, right? The squares, the perfect squares. 17 squared, 289. 10 squared is 100. Square root of 261 squared, 261. So we did not even need our calculator for that. All right, we use the symbol to eat the larger number. That is our chosen symbol. That is a less than sign. So our answer is acute, less than. Let's work 15. we're going to learn a shortcut for today. 15. Step 1, draw an equilateral triangle. Step 2, then step 2, draw the altitude of said equilateral triangle. So altitude, equilateral, check, check. The side length is 10. We're trying to find the length of the altitude, so that's our x. And so what skills do we have? What tools do we have in our tool chest? We have Pythagorean theorem. So we're going to learn some more things, some special things. But right now, all we have is Pythagorean theorem. This is 5, this is 10, and this is x. Everyone okay with that? So I'm going to dive right into 10 squared minus 5 squared, if that's okay with you. I'm looking for a leg, so I am subtracting. I'm getting 75. And then the rest is just factor treating to 75. Square root of 75. 5 root 3. I think it's, yep. So the altitude length is 5 root 3. Like I said, I will teach you a trick to find that on Thursday. I like 26. Let's do that one. Looking good. All right. In order to find a missing side of a right triangle, we need to know at least 2 of the sides. So I know one of the sides for sure. I know that this 8, that length in a rectangle at least. Oops. Second. I was trying to be fancy. That length I can slide over, and it is equal to that length right there. So I know this is 8. Now I need this length right here, and I can find that using subtraction. 18 root 2 minus 16 root 2. Because I know from here to here is 16 root 2. That's the whole reason we learned how to add and subtract radicals. It's for stuff like this. 18 root 2 minus 16 root 2. 18 minus 16. 2 root 2. So, Pythagorean theorem. A squared plus b squared equals c squared. I have a lot of students get this far and then literally square the 2 root 2 wrong. Not square the 2 and the root 2. So be careful. This is saying 4 times 2. So that's 8 plus 64 equals x squared. And I'm going to let you factor tree that and finish that out. I think I did the hard parts for you. Okay? So combine, square root, factor tree. I like number 30 because we have some variables here. You're not always going to do Pythagorean theorem with numbers, with integers. So let's use our variables. I love that there's a right angle here. Does anyone know what kind of shape this is? Because this is next unit. OMG, is a rhombus. Yes, it actually is a rhombus. And a property of a rhombus is that the diagonals are perpendicular, but that's for another day. All right. A squared plus, oh my goodness, so important, b squared equals c squared. The biggest mistake is to not put the parentheses around the 2x, to not protect the 2x. Alrighty, so we've got x squared plus 4x squared equals 25. That was really important. 1x squared plus 4x squared is 5x squared equals 25. X squared equals 5. X equals plus or minus the square root of 5, but we don't have negative sides. Cool here? So draw a right, I didn't say